This lesson is on factoring polynomials, and it's where I start with my students when I'm first teaching them how to factor polynomials. Because there's different ways of factoring and different techniques to use. This technique is the easiest, and so this works for what are called difference of squares. So that'll make sense as we go through this. So just real quick, hopefully you've already multiplied binomials together using FOIL or some other method. If not, I'll put a link up here. So you should know how to multiply binomials before you get into factoring. And so multiplying binomials, just a quick review. If you're going to use the FOIL method, so you would multiply the first two terms. So that would be x squared, and the outside terms, so that would be minus 4x, and the inside terms, that would be plus 4x, and then the last terms, that's what FOIL stands for. First, outer, inner, last, and that would be negative 16. Combine like terms here and you end up with x squared minus 16. All right, so that is the product of this. Now, this is a special case where you have a binomial that's being added together and the same terms being subtracted. And whenever you have this, that special case can always ends up with the result of a squared minus b squared, where this is a and this is b. So instead of doing FOIL, you can go directly to the answer. So I can do 5x times 5x, that would be 25x squared, minus 1 times 1 is 1. So just a shortcut if you don't want to use FOIL or some other method. I can do it on this one too. This is a, this is b. So 2a times 2a would be 4a squared, minus, it's always a minus, 3b times 3b would be 9b squared. And the reason that works is because the middle two terms are always going to cancel out when it's in this form. So really you just have the square of the first term and the square of the second term, and that gives you your answer. Now this resulting product is called a difference of squares. And so what factoring is, it's the opposite of multiplying these together. So we're going to start with this and we want to end up with that. Okay, so we're going to be going from here to here. And these polynomials are the easiest ones to factor, where you have the square of something minus the square of something else. All right, so how do we do this? So to factor a difference of squares, use the following rule. So if you have the square of something minus the square of something else, the factored answer will always be a plus b times a minus b. So if you're given a squared, how do you find a? Well, you find a by taking the square root. So just put a little note here. A is equal to the square root of a squared, and b is equal to the square root of b squared. Okay, so to find these a and b values, you're going to take the square root of those. Remember, square root is what number multiplied times itself is equal to that. So I think when we do some examples here, you'll catch on to this really quickly. All right, so let's do some examples. I have lots of examples here, but I'm not going to do all of them. So what we want to do is take the square root of this and the square root of this. And so the square root of a squared is a. Let me just write it like this. So the square root of a squared is a, and the square root of 4 is 2. And then you just make one of these plus and one of them minus. So the square root of a squared is a, because a times a is a squared. Square root of 4, you're saying what number multiplied times itself is 4, and that would be 2. Okay, same thing here. One of these is plus, one of them's minus. All right, so if you want, you can set it up like this. So you're doing the square root of 81 That's 9. I put a 9 in both of these. And the square root of x squared is x, because x times x is x squared. And that's your answer. All right. Now, this is one meant to trick you. This only works if it's a minus sign. So if it's a plus sign, then we can't factor this. And what we would say is that it is prime, meaning that it can't be factored. So if it's got a plus sign, it can't be factored. All right, so what about this? 9b squared. So let me set this up. So what times itself is equal to 9b squared? Well, 3 times 3 is 9, and b times b is b squared, so it's 3b. 3b times 3b is 9b squared. And the square root of 100 is 10. 10 times 10 is 100. Make one of them a plus, make one of them a minus. It doesn't matter if I put the minus here and the plus there. All right. So number 9. Let me just set this up real quick. Plus sign, minus sign. Square root of 16 is 4. The square root of a squared is a, so it's 4a. 4a times 4a is 16a squared. Square root of 121 is 11. So I got 4a plus 11 times 4a minus 11. All right, so let's look at this, multi-step factoring. So what this says is look for a greatest common factor first, then factor the difference of squares. So if you go back to these previous examples, there was nothing that could be factored out of these. So the truth is, when you have a polynomial like this, the first thing you should do is look to see, is there anything that can be factored out? And so if we look at these to see if they have any common factors, well, this is an a and this is a b, well, an a squared to b squared, so we can't factor out a variable. They have no variables in common. But what about numbers? So I know 9 times 6 is 54. 24, 9 and 6, well, 6 is a factor of 24, right? And I think that's the biggest factor. So the first step in this is we're going to factor out a 6. So remember, the way you do that is you divide each of these by 6. That's a 6. Bring the 6 out in front. And then 24a squared divided by 6 is 4a squared. Minus 54 divided by 6 is 9b squared. And really give myself room there. Let me write this out and give myself more room. I like using this pen. So 24 divided by 6 is 4a squared. Minus 54 divided by 6 is 9b squared. So that was step 1. Now I want to do what we did on the last page, and I want to factor this difference of squares. So I couldn't do that before. So like the square root of 24, a squared, is a long decimal number. And the same thing with 54. They're not perfect squares. So if I look now, the square root of 4a squared is 2a. The square root of 9b squared is 3b. So I can factor these. So don't forget to leave the 6 there. And now we're going to do what we did on the previous examples. So I'm going to write 1 a plus, 1 a minus. So 4a squared is 2a. 2a. 9b squared is 3b. And that's your factored answer. So it's got one extra step. So I can factor something out. All right, so let's look at this next one. So as far as numbers go, the greatest common factor of 45 and 20 is going to be 5. And I can also factor a q out of here. So I'm going to divide each of these by 5q. So 5q, dividing these, bring the 5q out in front. So 45 divided by 5. So 45q cubed minus 5q would be 9q to the second power. Remember, a power divided by a power with the same base, you subtract the exponents. So this is 3 minus 1. That's why it's 2. Minus 20 divided by 5 is 4. And the q's just cancel each other out. So I have this. So now I'm going to do a difference of squares here, like we did on the previous slide. So the square root of 9q squared is 3q. And the square root of 4 is 2. And that's my answer. All right, let's look at 25 here. So 136, I believe the greatest common factor is 4, and I can factor out a b. So I'm going to divide these by 4b. 4b, bring the 4b out in front. So that would be 25b squared. 3 minus 1 gives me the b squared, minus 9. All right, now we're going to do difference of squares. So square root of 25b squared would be 5b. And the square root of 9 would be 3. And that's your answer. All right, so let's do one more of these. All right, so on this one I can factor out an 8, and I can factor out a y. So I can't factor out an x because this one doesn't have any x's. So I'm going to factor out 8y. So 8y. So 8 divided by 8 is 1. Y's cancel out and just leave me with x squared. 32 divided by 8 is 4, and y to the third minus, or divided by y, would be y to the second. 3 minus 1. All right, so let's go ahead and factor this. So square root of x squared is x. Square root of 4y squared is 2y. And there's your answer. All right, so that's factoring polynomials that are a difference of squares. All right, these are the easiest ones to factor. So that's why most people start here when they're teaching factoring polynomials. So I hope that was helpful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.